this video, I will be talking about solid programming principles. So, the first question is, what is solid programming? So, solid programming consists of 5 different concepts, or principles, or practices, however you call it. But the idea behind is that to write maintainable code. It is important to write maintainable code because it is highly likely that your customers will come back to you and request more features, or you will have to fix some bugs and stuff like that. Of course, it really depends on in which situation you are working. For instance, if you are developing an enterprise application, what I've just said is most likely possible. But if you are maybe just doing your own stuff, for some small customers, you may not be in that situation, so you don't have to worry about it that much. But still, there are cases where solid programming doesn't make sense. But let's actually first explain what solid principles are, and then we can go from there. So the first item in solid principles is single responsibility principle, and the second item is open-closed principle. Third item is list cost substitution principle, and the next item is interface segregation principle, and finally it is dependency inversion principle. By the way, some say it is dependency injection principle, but I think dependency inversion makes more sense here, which we will be explaining soon. I mean the difference between dependency inversion and dependency injection. So let's start with the first one, single responsibility principle. So the idea of single responsibility principle is to have components that do only one thing at their own abstraction level. If you wonder what an abstraction level is, let's start with the abstraction itself, the meaning of abstraction. In our daily lives, we always see abstraction in some sort of. So, for instance, like when you drive a car, you don't really care about how the engine works, or what you do, what happens when you push the gas pedal and things like that. So this is an abstraction. So you only see gas pedal or steering wheel and things like that, but you don't really see how the engine works. And that is a deliberate decision that the engine and all of its internal components are abstracted away from you, so that you can have a better and more pleasant experience with your car. And we are humans, and we can actually deal with a certain amount of things at the same time, and it will be really hard for us to deal with the engine while we drive the car and think about the engine and stuff like that. So it is pretty much similar to programming as well. So when you abstract your code away, when you develop your own components, which can be a class, or depending on the language and language you use, it may be a different thing. But in object-oriented programming, components are usually classes. But of course, depending on which level you're talking about, a component can be a module, and goes like that. So let's not go into that too much. So in the abstraction, so from that explanation, the abstraction level can be different. For instance, a car. Let's actually think about this. When you develop a bank, basically a bank object, can consist of accounts, employees, ATM machines, and a bunch of other things, right? So excuse me. So but let's go into the bank, and we see employee and we see ATM. So profile, for instance, let's take a profile. A profile should abstraction. What it abstracts away is the profile information. So it only exposes you the information about a person's profile or account, for that matter. And you can get from the account class, you get the name, the last name, and maybe you have some methods like deposit money, withdraw money, and stuff like that. But what happens when you deposit money is none of your concerns. It is the internal operation of the class itself. So when as a consumer of that class, account class, when you say, okay, I want to deposit $1,000 for this account, you don't really care how that deposit operation takes care is done. It may be, for instance, go to a different, maybe using some HTTP to go to the RESTful service and to the deposit, maybe hitting some database or whatever, but it's not of your concern. You only know that, I want to deposit some money. And the profile class with that understanding in mind, profile class only exposes the items that it thinks necessary, nothing more than that. There are a couple of other reasons why. The first one is you don't want to confuse your developers, and what happens when you see something like from the profile? What happens when you consume your profile class and you see a method that says perform HTTP operation to deposit money and come back and do this, whatever? That's confusing. But you only say, okay, I just want to expose couple methods, and that make more sense. They make sense, like deposit money, withdraw money, and that's it. Maybe get name, set name, and stuff like that for the account, but it does make sense. So you only expose what's necessary for the outer consumers. The second thing is you want to keep the consistency of your internal operations of your class, or internal state of your class or component. The reason is because once you allow people to interfere with the internal operations of your class, you basically increase the possibility of a defect in your app or in your library. So, for instance, some languages allow people to override members of the classes by default. What happens when someone implement or inherit your class and change some of the internal methods, or some methods that will probably cause the corrupt the internal operations of your class, and you don't want that. Why? Because it will lead to bugs and unexpected behaviors, and some of them are usually unexpected behaviors are so hard to debug, and it will cause money, time, frustration, and a lot of things. So you want to keep it simple and stable and consistent. So that was the abstraction. Some people kind of confuse the abstraction with encapsulation. That is normal, but it is really a matter of where you look at this from. So if you look at from the class itself, or from within the class, it is encapsulation. Why? Because you basically keep the internal state of your class, and then all the internal operations of your class, and that's called the encapsulation. You don't allow people to touch and interfere with the internal state that it is necessary to keep your class stable and function properly. So if you're looking from within the class, it's encapsulation. But if you're looking from the outside the class, then that is abstraction, because as a consumer, you only want to access the methods that makes sense to you and sense to what you do. You don't want to see some bunch of weird methods, or some incorrectly exposed items, methods, members, fields, whatever, to you. And then you want to kind of read and understand the class and its operations. So that's basically abstraction. So let's go from there, and I guess it is understandable now. So what is the abstraction level from all these explanations? So if you are at the profile class level, that's your abstraction, and your profile only does one. Sorry, your account only does one thing at its own abstraction level. It only does account-related things: depositing money, withdrawing money, getting or setting the name of the account owner and stuff like this, right? But if you go up at the abstraction chain, let's say, then you will see a different abstraction level. For instance, let's look at the bank. A bank does only one thing, and that is bank-related stuff. So a bank does not sell cars, let's say. It only allows people to keep money, withdraw money and stuff like that, and it has employees and stuff, but they're all one single entity. That is the bank. And at this bank abstraction level, we see a single responsibility principle because we expect a bank to behave like a bank, not anything like that. But if you go into if you go to below that abstraction, you'll see that a bank consists of, as I said before, employees. An employee only does one thing, whatever an employee is supposed to do, and an account is supposed to do one thing, and everything is supposed to do one thing, and that is what they are expected. And then when you combine more things into more of those components into one component, that the logical semantics of that component is now one thing, because you only see that that component is doing one thing. So that is the single responsibility principle and the abstraction and abstraction level. So you can't say a bank is doing a lot of things. No, it is only doing one thing, and that is what a bank is supposed to do. But so don't confuse, a single responsible different principle with the different abstraction levels. They're different. So let's go to the second topic. But before though, and you may wonder why we do care about singular responsibility principle. As I explained before, the first one is to help people to use your classes easily, use your components easily, and then also the other definition of singular responsibility is that a class or a component is it should only have one reason to change. That's some people, that's for some people how they describe it. So one class, one component should only have one thing to change, and that's it. So for instance, you don't modify your bank class for I don't know, for if something happens to your garden, you're right. I mean, they're total separate things. Don't care about each other. So let's go back, and then the second reason why you should conform the single responsibility principle is that you want to develop reusable components, and then the more granular and in terms of responsibilities there are, the better reusable they will be, so that you can easily swap different classes or reuse, those classes in different areas. And the third one is the second thing that I explained naturally leads to the third item, which is when you develop within a team, it is important for you to be able to work in asynchronous, not synchronous, but asynchronous. The reason is because by definition of synchronism is that you basically depend on each other when you develop your app. So without someone develops something, you cannot go ahead and develop your own stuff. That is a synchronicity I'm talking about. But in an asynchronous environment, people can easily work in parallel, and that is what we want. So we want that people can just take one piece and work on that easily, and the other people can work in different things easily without really stepping on each other's toes. And that's the thing. So I think there are really important reasons why you should do a singular responsibility principle. So the second, I'm not gonna talk about all of them. This is gonna be part one. But let's talk about the second thing, which is open closed principle. The simple idea here is that open close your class, your components shall be open for extension, but closed for modification. Well, what does it mean, and why we do care about that? So the idea behind this is that you want to touch the existing code as less as possible. You don't want to interfere with the working system, so that you don't introduce bugs. The more you touch the existing code, the higher possibility you introduce to your system for a bug. And now you don't want that. And believe me, that as a software engineer for years of experience, I've dealt with that type of problems all the time, and I don't like it. Anyways, let's go back to topic. So, and the principle says, your class shall be closed for modifications because of the reason I just explained. But it shall be, but you're not gonna stop there. I mean, you eventually will add more functionality, which is the essence of our software development processes, right? And then, but what happens when you need something to do something like that? It is the second part, which is open for extension. So you want to extend your class without touching the existing code. And of course, there's some shortcomings or some weak areas of that definition. But basically, for instance, if you make your class virtual, well, in C# you can't really make it virtual, but it is virtual by default, which means you can inherit that class, but you can make the members, like methods, virtual or protected. Sorry, virtual or not virtual, or sealed. Sealed means you cannot override it, or you cannot inherit it based on where you apply that sealed keyword. So for instance, if you apply that keyword, sealed keyword at the class level or the class itself, it means that it's final and you cannot inherit it, which is final is the keyword in Java world. And then there's some differences though between Java and C# if you care though, but let's talk about the C# in this case. And then you can make your classes, your members sealed or virtual, so if you want to override them. So some people say you can do that. I mean, you can do this, like you can extend your class and then override some of its members to basically introduce your own new thing instead of touching the existing code and basically touching the entire system. I think it is a good way of dealing with that, but there are also different ways, for instance, like composite patterns, different design patterns that you can follow for like strategy pattern or decorator pattern and stuff like that if you want to extend existing functionality without really touching or changing it. I think I kind of like design patterns better in this case, like strategy pattern or decorator pattern, and goes like that. But either one works, I guess, fine. It really depends on the situation you are in. So go whatever it's better for you. And the final for this one is, and then I guess I already talked about the importance of the open-close principle. I'm not sure if it makes sense to you, but it makes total sense to me, and I can agree with that. But impossible to do that all the time. Maybe I should say it depends on the phase of your project. For instance, if you're still with the interface of understanding the customer requirements and showing them something work usable so that they can say, okay, this is what I want or not what I want, kind of thing, then applying solid or design patterns doesn't make sense, because what if they don't like it, and then all the efforts that you do to perform solid programming is gonna go waste, and you don't want that. So you wanna, when you do like prototyping or you know, programming like that, you just keep it simple. And of course, I mean, don't make it a mess, but just keep it simple and don't worry about solid that much. Because and then you can always come back and quickly change based on the scope or based on the size of the project. You can change your project after the requirements and the agreements are done with your customer. I think that's enough for today. Well, we're gonna have possibly a part 2 and part 3 that I'm gonna talk about. In those, I'm gonna talk about the third one, which is the Liskov substitution principle, which is another good one, and the fourth one is going to be interface segregation principle, and the last one, which is probably will be in part 3, because I'm gonna talk more about some programming concepts like try, or kiss, which is simple and stupid kind of thing. So I guess 3 parts will be better, and honestly, you will probably fall sleep when you watch this video. So there's no really good reason to keep it too long, I guess, because I really want to give you something useful in these ASMR videos, and that's why I just want to keep it, short, to the point, and relaxing. Alright, I hope you enjoyed this my first ASMR video, and what I've explained so far about solid programming. And if you have any questions, please let me know. I can explain or clarify some of the concepts that I tried to explain in this video, especially encapsulation and abstraction. But I think it's pretty much all. Thank you guys, and yeah, you guys have a great day.